So now comes the question. Some of you were asking, and Lakshita is also missing. Lakshita is here, right? Gitesh is also missing. Okay, anyways, so I have just reminded everybody. Hopefully. Okay. I'm sorry?
Lakshita, I'm in the class.
Yes, Lakshita. I was seeing your daddy's name, that's why I was wondering. Where did the child go? Okay, alright. So let's get started. I would request you all to turn on your videos so that I would have a fair sense of whether you guys are able to follow me, not able to follow me, or and again, it is very important for all of us to know that everything that we do reflects on how we are studying, how we are learning, okay? So be mindful of what you say, not only for yourself but for the entire class. That's my request. Alright, so let's get started. What are you going to learn today? What did you see in the message?
I don't have a phone. So.
Okay. Understanding slope and understanding similar triangles and the correlation with the slope.
Wait, the slope after is like slope like similar to an equation, like with graphs?
So math has no scope for assumptions. I said I will teach slope. If you know about slope, then you would know about it. If you don't know about slope, you have to hold your horses till I teach you guys. Okay? I'm just trying to cut down on the unwanted discussions because that is not productive by any means. I cannot be more explicit than this. Okay? So, now the question to you all is, what is your understanding of slope? What do you know by slope as a literal meaning of the word slope?
A slope is like a hill, but like more like inward.
Okay. Slope is a slope, sliding down the slope. Okay.
Slopes can be used to like.
What is a no? Tell me, what is a slope? What is your understanding of slope?
It's a line that goes a slope.
Okay. Okay.
But it has like an X and Y chart, so
Leave it there. Yeah.
it goes down to like.
It goes something like this. Okay. This is one very practical example.
So a slope, it goes down and then it goes up again.
Okay, got it. Leave it there. You're not adding value by giving more and more sentences. That's why I'm stopping it there. No, let me go to other kids also. Let's hear them. Dikshita, what is your understanding of slope?
Like a line where it goes like slanting.
Okay, slanting. Okay. Sagnika, what is your understanding?
It's like where you divide 2 points, I think.
Okay. I'll just say yes. I heard you. Okay. Yeah, you had one last point. Okay. Now, slope. We all have grown up seeing a slope. We have seen kids sliding down the slope. Yeah, Aryan. You're saying something? Yeah.
Never mind.
Alright. We have seen the kids sliding down the slope. Okay? This is one slope. This is other slope. Even this could be another slope. This could be another slope. Imagine a kid sliding on this slope versus sliding on this slope. Imagine this. No, see, this is what you can relate, right? If you are being asked to slide on this slope, okay, you'll not see the kid even sliding because probably it's almost flat. Here this is probably working fine. This will be pretty fast. Here this is going to be fast. You literally fall. Okay? Now, if you look at this slope, what will you say? This is very steep. This is very much vertical.
Like a mountain.
This is very much vertical, not a mountain. You're think of a slide or a slope, which is like 5 feet in length. Will that be equivalent to a mountain by any means? No. Will not go there. Now, I'm saying this slope and this slope. from here to here if you go, you see that it is becoming more and more steep. This is almost very shallow, steep, steep, steep. And if you want to make more fun, if you just literally want to throw the kid from here and kid falls here without sliding, this is very steep. Yeah? This is like this is when you will throw the kids from this slope when the kid is not studying in the class and bothering everybody else. Now this is a message for some of you, okay? Yeah.
Wait, can a slope also go like up slanted, or does it always have to be down slanted?
Doesn't matter. See, if you look at from here, it will look like up slanted. If you look at from here, it will be down slanted. Doesn't add any value. Same thing. It's just a way of how you're looking at it. Okay? So, you have seen some interesting part of the slope, right? From here to here, becoming steep. Yeah, everyone.
Sir, so like at the lower, like at the lower, like the angle, like the more steeper it is.
Yeah, so we have not gone to the mathematics part of it yet. We are still looking at the practical side of how we look at the slope, right? Yeah. Now we'll go there slowly, okay? So we are starting from here. Then this is the slope. If in your school the kid is sliding down this slope, maybe the kid has to put a lot of effort for sliding or moving forward. This is slightly better. This is faster, very fast. This is punishment. You're literally throwing the kid from here. Kid comes here without sliding even. Yeah. Now, in a more literate way, if we look at it, we are saying that the slope is becoming steeper, more steep, more steep, more steep. Yeah. Now, I said that we will stop talking about linear equation, but then I realized that if we don't talk about the slope of the line or the different formats of the linear equation, our learning of the linear equation would not be complete. So that's why. Who got a prize today? Nobody. Why were you celebrating then?
Because nobody needed equation.
Every day when you come here, my promise to you is I'll make sure that you guys learn or you practice. So there's nothing to cheer up. There's no cheerleader here. Okay? Yeah.
So slope is on the graph like linear equations?
Let's not jump. I'm saying that slope, very basic understanding of slope is okay. Slope is a line, is like a line, which we can relate with what we have seen in the schools where kids come down sliding the slope. And slope is good or bad or steep depending on how slanted it is. Yeah? Or what is the angle of that also? Yeah, that could be another way. Now, let's look at it against a graph in a coordinate plane. This is a line. And line comes from a linear equation. Yeah? Let's say my linear equation was this, y equal to 3x plus 7. And that is what was drawing this line for me. I'm just picking it up. So, here we see there is a slope, there is an inclination, there is an angle of the line. And if you stretch that further, you will see this is making angle with x-axis. If you stretch this in this direction, this is making angle with the y-axis. Yeah? So you see that a line is making angle with the x and y axis.
It looks like a right triangle.
It will be a right angle always. Any line, even if you draw this line, right angle always. Yeah? Because this is your x and y axis is a 90 degree anyways, right? So any line this way, that way, it will be right angle only. What I am trying to say here is, you see a line. If you look at that line in a coordinate plane, you will see that it's making angle with x and y axis. Now, let's look at another line. Let's say y equal to 75x. I'm just making it out again. 22. This is drawing another line. Okay. So far I'm just giving you guys the boundary, okay? I'm just giving you guys the conceptual view of how you will look at things before we get to the mathematical side of it. It's very easy for me to just teach you the mathematical side in 2 minutes and run away. That is not the idea. I want these things to be, deep rooted in your brain, conceptually. Now, this was my first equation which helped me draw this line, let's say, okay? And you see that this is making angle. Now this is my second line. This is making another, this is the second equation which is drawing another line for me, let's say this one. Again, when I stretch that, I see that is making angle with x and y axis. Okay? What is the difference between these two lines that you see by looking at the visual side of it without going into mathematical details? This is less steep, this is more steep. Look at this angle again. This angle is smaller, this angle is getting bigger. Yeah? Your angle with the x-axis is becoming bigger when you make it steep. You make it further steep, this angle is becoming even bigger. This angle, value of the angle is bigger, okay? It might look smaller here, but the value is more. So this versus this angle is bigger, this is smaller. Yeah? Yeah?
So then if it's like a straight line, it'll be the biggest, like for being 180 on a straight line? Or
I mean, that is how you interpret, but what will you do with this? This is slope. Yeah? Hi, Sanvi. Alright.
My internet wasn't working for some time, that's why I was late.
Not a problem, Beta. That's okay. What we are trying to do today is, we are trying to learn. We have been learning linear equation for some time and everybody is tired. Right? But I'm not. I'm not trying to teach you guys the same linear equation again. We are trying to look at the other side of the linear equation, which is very much needed. Because when you say linear equation, there could be multiple forms of linear equation. And before we go into those forms, we are trying to understand that, okay, a linear equation draws a straight line for us. But then, what are different properties that we can look at? We are looking at something called slope of a line. If I have a linear equation which draws a line like this, versus line like this, versus line like this, versus line like this, there's a difference. And that difference is in the slope. Something is shallow, steep, further steep, negative. That's what we are trying to see here. So now, let me repeat what I said, and I would want to hear from you guys. So this was my first equation, which let's say drew this line for me. I just extended it and saw it touching the x-axis here, okay, and y-axis here. This is my line 1. This is my line 2. I use this, let's say I drew this line. This is my line 2. By looking at it visually, I can see this is less steep, this is more steep. This is more vertical. I would probably not want to go down this slope if I have to slide.
Wouldn't they intersect also, but in a different way?
What is that?
Wouldn't they also intersect?
I don't care. Because I'm not trying to learn that part. I'm not trying to solve it like what we have done in the previous class. This class is more on the slope part of it, okay? I'm just looking at the slope. By looking at these two lines, I see that this is more horizontal, this is getting more vertical. And what is my observation is, this angle between the line is becoming bigger. This was a smaller angle, this is a bigger angle, right? If this is more steep, this angle becomes even bigger. So, again, we have not learned anything so far. Yeah, Vivan.
So can calculate the angle of the slope. Can it ever be like more than 90 degrees?
See, it's a very interesting topic, okay? We can go into a long debate. Why? Because if I have a line like this angle is small. If you're looking at it from this side, this is lesser than 90. Look at it from this side, it's the same line. Yeah? This angle is already more than 90 degree. Yeah? So what I'm trying to say is, when you look at a line, depending on which side you're looking at it from, your angle would be less than 90 or more than 90. Unless it is a right angle, where from both the sides is 90. Yeah? Make sense? Okay. Now, coming back to this one. By looking at these two lines, two equations, I have drawn two lines, and we clearly see that, okay, these two have different slopes. Now, what is the meaning of slope now? It's getting more interesting now. When I see slope is less, here I see slope is less, here I see slope is more. What is the interpretation? How do you think about it? When I say slope, this line has a very little slope. What does it mean? When I say this line has a bigger slope, what does it mean?
It's more vertical.
That is still subjective in nature. Since I'm looking at the coordinate plane, I'm trying to see how I can relate coordinate plane with the slope. So I have given you guys now one more clue. That okay, I have a coordinate plane, I have two lines with two different slopes. What does it mean against a coordinate plane? So, okay, when I have a coordinate plane, I'm looking at things with x and y, correct? When I'm looking at a coordinate plane, I'm looking at x and y for everything, right? Be it every point, I'm looking at the x and y value. Now look at this. Now, I would want you guys to pay more than 100% attention in the class. Look at what I'm doing right now. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. This is my line 1. And this is my line 2. This looks parallel.
I thought you said that.
No, wait. You don't have to jump. This is my line 2. I don't want you to get me distracted, okay? I'll not let you get me distracted, okay? I'll tell you why. Because I have a fixed agenda in mind. Now, look at this line. These are the points, okay? When x is 2, what is the value of y? This point, if you look at this, when x is 2, y is 4. You come to this point. Here what is happening? When x is 4, x became 4, y became 2. When x was 2, y was 4. When x became 4, y became 2. Now look at this point. When x is 3, what is the value of y? That is also 3. Approximately, right? I mean, this might not be accurate. For the first line. So, when I'm changing value of x from 1 to from 2 to 3, value of y decreased from 4 to 3, decreased by 1. One increase of x is leading to one decrease in y. Is that okay? Here again, when I came from this point to this point, again one increase of x from 3 to 4 led to one decrease of y. Are you guys with me so far?
Yes.
Yes, sir.
Now, look at this guy. Look at this point. What is the coordinate for this one? X is 1, y is 3. X is 2, y is 0. Here in this case, in the first case, every increase of x was leading to one decrease in y. In this case, one increase of x from 1 to 2 led to 3 decrease of y. In this case, when the slope is more, y is decreasing faster. When the slope is less, y is decreasing slower. Are you guys able to follow me? When the slope is less, when this is almost flat, when every increase of x is leading to some decrease in y, every increase of 1 is leading to one decrease of y. Look at this one, which is much steep. One increase of x has led to big decrease in y. Yeah? So, the interpretation is this. When the slope is less, your y is decreasing slower for every increase of x. Or the change in y is slower. When the slope is more, your change in y is faster.
So like when you're sliding down this thing, like the slope, if it's more vertical, then you're going down faster. But if it's more steep, you're going slower.
Yeah, same way, right? Like, I mean, now you set that analogy with how a kid would slide down the slope. If the slope is less, kid will slide slowly. If the slope is more, kid will slide fast. It is vertical. You imagine how would the kid come down, right? So when the slope is less, y value is changing slowly, kid is sliding slowly. When the slope is more, y value is changing fast. Now when you say y is changing fast, what does it mean is y is changing for every change in x. So the rate at which y is changing, coming down or going up. Let's say if I talk about a line like this, my line will not be always like this, right? My line could be like this also. Yeah? This is less steep, this is more steep, this is more steep. So here, every increase of x is leading to increase in y. So we are not saying that it's always decrease of y or increase of y. I'm saying change of y. Every change of x is leading to a bigger change in y. That is a reflection of slope being more. Okay?
Teacher, would it be like if 8 by 7, okay, if it changed about 1 by 5, it will be changing to 7 by 6, right? Would it be a big change?
I don't care. When I say I don't care, I don't care about the numbers. It's very simple. If every change of x equals 1 is leading to change of y by 1, that is one rate. If every change of x is leading to every change of 1 in the value of x here, out of here, every one change of x is leading to 1.5 change in y, that is also faster. These are relative terms, right? This slope versus this slope versus this slope versus this slope. These are relative. This slope versus this slope. This is faster. So I'm not quantifying it. I'm not saying 1 by 5 versus 7 by 5. I'm not saying this. Anything which is bigger is a bigger slope. And when I say a slope is bigger, what it means is y changing fast. Be it upward or downward.
7 5 is bigger than 1 5.
You are more worried about this one, I'm not. I just give you an example that if I'm not trying to prove this, okay? I'm not trying to say that. I'm saying if my slope is more, that means the change in y is faster. Okay? So that's what I'm trying to say. Did everybody on the screen understand what I said?
Yes, sir.
And are you able to relate that? Now, whenever you talk about a slope of a line, it simply means how fast your value of y is changing. If y is changing slowly, it can go, it could increase or it could decrease, doesn't matter. If y is changing slowly, slope is less. If y is changing fast, slope is more. Yes. Now I'm ready to take up questions. Yes, Dikshita and Pranav.
Can you repeat what you said again?
So, in this case, right? I'm just giving you an example again so that you can relate. In this case, this was, let's say we took 2 points here on this slope, okay? This is 2 and 4, meaning the x coordinate is 2, y coordinate is 4. We came to this point. Here the x coordinate is 3, y coordinate is also 3. We took one more point on this slope, on this line. X coordinate is 4, y is 2. By looking at this, what we saw was when x was changing from 2 to 3, y value changed from 4 to 3. When x value changed from 3 to 4, y value changed from 3 to 2. Meaning every increase of x by 1 led to one decrease in y. So every value of x changing by 1 unit led to 1 unit decrease in y value. Okay, that was the change. Look at the second slope here. We took this point and this point. Here the x coordinate is 1, y coordinate is 4. Here the x coordinate is 2, y coordinate is 0, this point. We took 2 points on the second slope. Here, when x changed from 1 to 2, y changed from 4 to 3. So here y is changing. For every one change of x, y changed by 3 units. So here y is changing fast. Earlier, just by looking at the picture, we said this is less slope, this is more slope. Now we are relating that in the coordinate plane, where we are saying that, okay, fine. If I talk in terms of coordinate planes, slope means how fast is y changing for every change of x. Make sense?
Yes, sir.
Okay, let me go to Pranav before I come to Arun. No, wait, you have to wait, you have to wait, no, you have to wait, you have to wait. There are people waiting, I'll come to you. You cannot jump the queue and then get the priority, okay? Yeah, Pranav, please.
Sir, what if like the slope was 0,0?
Slope is never 0, 0, it's a point on the line. So, here, in case you look at slope as how fast is y changing. So, let's say, when you say 0, 0, that means your line is crossing this point, okay? So, this is just a point, 0, 0. What will you do? You look at one other point here. Okay, when let's say here, this point was x was minus 2, y was 2. And this is 0, 0. So you will not look at individual points, you look at the change. This is here, x is minus 2, here x became 0. So when x changed from minus 2 to 2, y changed from 2 to 2. So you are saying, okay, for every change of 2 in x coordinate, y is also changing by 2 units. That is your rate of change. So when you look at the slope, you always look at how is my y changing for every change of x by 1 unit. That rate. Okay, Arav was looking. Yeah.
Can I go to the bathroom?
Oh. Quick. Yeah.
So now like for analysis about like the thing,
Huh?
like it's increasing and that stuff.
So slope could be increasing or decreasing both.
So it's technically a rule.
It's a change. That's why I never said how y is increasing for every increase of x. I did not say that. What I said was how is y changing for every change of x by 1 unit. So if my slope is like this, here for every increase of x, y is decreasing. If my line is like this, for every change of x, y is increasing. So that's why instead of getting into the trap of increasing or decreasing, we said change. That is what tells us slope also, right? See, whether the slope is like this or like this, if it's changing the same rate, meaning the kid will come sliding down the slope at the same speed, be it this way or this way. This is just an alignment. What matters is how scary the slope is. Yeah? Yeah, makes sense? Everybody here on the screen?
Yes, sir.
Now let's get to the mathematical part of it. So, some interesting fact for you guys. Myra is my own daughter, right? You all know that?
Yes.
She lives in the same house like I do. She's still joining it online. So, and she opts not to say anything. Myra, are you following me so far?
Yes, sir.
Okay. So that's what. You guys are getting more interesting with invent of technology, and that is good. I appreciate that. I've been making my living with technology only, but then sometimes it gets little too much. Alright.
In school, they're encouraging us to use AI.
That's not needed, out of syllabus. Alright, so let's go to some interesting part of it. So far we saw, okay, fine. If I say slope is less or slope is more, we said, okay, here y is changing faster or slower. Now let's put that in a mathematical form. If I say a slope of a line, I will say second point on the y if I have 2 points on this line, this is saying 3, 8 and this says 5, 6. Can you find out the slope? I will say this is my first point, this is my second point. Look at the y value of this point minus this point. How y is changing for how much of change of x? 8 minus 6. This is y2. This is my, okay, this is, let's say this is y2. This is second point, this is my first point. Whatever, right? Or you can say fine. I will say this is my y1, this is my first point and this is my second point. So y1 and this is y2. So 6 minus 8. This is y1, this is my second point. What is that? y2, this is y2 minus y1. 6 minus 8. Divide by x2 minus x1. So this is 3. 5. x2 is this minus x1 is 3. Becomes 6 minus 8 minus 2 divided by 5 minus 3, 2. This is minus 1. Why? So minus 1. What does minus 1 mean here?
It's a slope.
Slope? No. It's a slope any which way. It's a decrease. It's going down. It's decreasing. So here, whatever we learned that this is a lesser slope, this is a bigger slope, right? We are putting that in a mathematical form. We said that, okay, at what rate y is changing for every change of x? How much y has changed for this much change of x? That will give me every unit change of x. So second point's y minus first point y, how much y has changed divided by total change in x will give me per unit change of how much is the change of y for every unit of x, right? Here let's say 2 units of y change for 2 units of x, right? So per unit change is minus 1, meaning it's a slope which is negative, it's going down.
It's going to the quadrant of 2.
Did I say that? No, don't go there. I'm saying this is a decreasing slope. Meaning, whenever you see a slope value as negative, that means it's a decreasing slope. If you had an equation like this, you had an equation which was drawing a line like this was your first point 3, 5, and this was your, let's say, this is, let's say 6 and 9. So this is your first point, point 1, and this is your point 2. So y2 minus y1, meaning how much y changed from first place to second place, divide by, for the change of x. This is your slope. So y2, what is y2? This is 9. 9 minus y1 is 5. Divide by x2 minus x1. x2 is 6 minus 3. 9 minus 5 is 4. 6 minus 3 is 3. 1 by 3, 1.33 or something. When you look at this number as a slope value or this number as a slope value, what does it mean? This is decreasing, this is increasing. Meaning, how will you relate that? When this is decreasing slope, meaning value of y is coming down. When you increase x, value of y is coming down. When this is positive, meaning when you increase x, value of y is also increasing. So, if you see a slope as this and line drawn as this, then this is right. This looks right. I mean, even if you have not validated data, you can say, okay, fine, this looks like a positive slope. Yeah, because x is increasing, y is also increasing. If somebody gives you a slope value of this and says this is your line, you should have a doubt that yeah, this is a decreasing slope actually, because every increase of x is bringing y down. This cannot be. This picture and this value of slope doesn't go together. Make sense?
Yes, sir.
Okay.
Yes, sir.
So this, how much time do we have? Can we? Okay, we have 20 more minutes. So we looked at linear equation, we looked at slope. Can we marry these two concepts and learn a third thing called a linear equation in a slope intercept form?
Z.
What is that?
Z.
What is that? I said linear equation in a slope intercept form.
Oh,
I feel like the slope is gonna intersect to make a linear.
I think.
It's a form. Okay.
So do we have to use like the linear equation, like it's like two base equation, and then we can convert it into a graph, and then for slope we can like use the formula for y equals, and then so then we can see the rate of change.
I'm waiting to see if you have a break or you don't have a break. No, so you are going way too far. See, you're trying to solve or you're trying to relate with what we done in the previous class. I'm saying a linear equation in a linear equation. I made that statement. A linear equation in a slope intercept form. So I'm saying we have seen enough of linear equation. I'm saying, can we look at right now we were drawing the line, finding the slope from the linear equation. And now we are saying, okay, fine. We know linear equation and we know the slope. Can we put these two concepts together and look at a linear equation as in this form? Everybody here on the screen. This is the linear equation in the slope intercept form.
So then how will we convert M and C, because then
No, leave some job for the teacher also. Otherwise I'll become jobless. Yeah. So I said that this is the slope intercept form. I'll peel off the onions also. Okay, I'll explain that. Don't jump to a conclusion and then you struggle. I will also start wondering, oh, did I look at the right concept or not? Okay, and if you go very far in the wrong direction, right? If you put that map in the GPS, it's an extra work for the GPS, right? It has to come back to the original position and from there you have to find out direction. So let's not go very far. Alright? So we learned about the slope, we learned about linear equations. I'm saying that can we put these two concepts together and learn something that is called linear equation in a slope intercept form? Any guesses? Any meaningful guesses? No, you have just your quota of guesses. Okay, wait. Yeah, any other guesses? How do you relate these two things? Thanu and Advik can try. Arav has exhausted. You have exhausted your limit. You will only get a limited window.
What do you say?
I'm saying, I know linear equation. We know slope of a linear equation also. I'm saying that this is the linear equation in the slope intercept form. Any guesses around this one? Yeah, Vivan, you have raised your hand.
I think it's like it'll give you like an equation and like ask you to like make like a slope and like describe like an equation out of the slope, or they'll just give you like the slope and like take 2 points of it and like describe like the line of that.
Yes and no. So yes and no as in, now we are saying that okay, we learned about the slope of an equation, right? That okay, this is my equation. This draws a line for me. From this I can find out the slope y1, y2, and I get the slope. And we learned that m equals y2. How much y is changing for every change of x? That's what we were doing.
What's the C mean?
Right. So it's a two-step process. First mystery is solved. This is your m.
And we know
oh yeah, you separated because you moved y
So-
outside. And you would
See,
actually
I was not trying to bring a surprise. I was just connecting the dots. When I taught you guys slope, there was a purpose for teaching you the slope. I'm saying this was my slope. How much y is changing? Can I plug this into an equation
Sure.
and make that as my equation? Yeah.
will. So if we found out how much the thing can go move, so then that'll be the rate of our equation, and then
No, so here is the thing. Okay, here's the thing. You guys get very excited to rush for an answer. Wherein my objective is to focus on the concepts. I'll keep bringing you guys back to the concepts, because if I get you going in the direction to hunt for the answer, concept will go missing. Now what I'm saying is, conceptually we know what is a slope. Simply put, slope says how is my y changing for every change of x. I did not say increase or decrease. I said how is my y changing. Yeah, everybody with me, right, on the screen?
Yes, sir.
I will use this understanding of the slope to derive an equation. Now, part of the mystery is solved. M is known. What is this C? That is why when I said slope intercept form, my every word is worth $1 million. You have to keep on mining those dollars.
trust.
No, I said my every word is worth $1 million. So is the case with you guys. You guys waste your millions of dollars every day talking nonsense. I am saying preserve them, because your every word is worth $1 million. I said slope intercept form. So this is your slope and this is your intercept. This was the $1 million information I was talking about. Now you'll ask me what is intercept? What is $1 million? Anyways, I don't know how long it will take for us to find out $1 million, but okay, let's focus on this virtual money for now. Yeah, Vivan.
Does this include intercepting two different slopes and trying to find the center point of them?
No, so this is a slope intercept form for a linear equation. So we are not trying to get into the complication of dealing with two lines. We are talking about linear equation in a slope intercept form, meaning one equation existing by itself. Okay? Alright. So when I said slope intercept form, this is the slope which says how shallow or steep the line is. And this is your intercept. What intercept? This is the intercept, or this is where this line is intercepting the y-axis. Meaning, if you look at this, y equal to mx plus c. Okay, this is my slope, meaning what rate my y is changing for every change of x. Okay. Now imagine, I'm saying this is intercept form, meaning where it is intercepting the y-axis. Where will it intercept the y-axis? Where the value of x will be 0. And this is the point where x is 0, where this will become 0. So this c is nothing but the intercept. Where if you have an equation like this, y equal to 3x minus 2. Now if you look at this equation, this is your slope and this is your y-intercept, meaning your line with this equation is touching y-axis at minus 2, 0 minus 2. Y-intercept, okay, mx plus c is minus 2 here. So this is the point where it will touch, and I can safely assume that this will be a line like this, because it's the slope is 3, meaning it's an increasing one. So every increase of x will lead to increase in y. So if I have, let's say somebody gives me a question, say okay fine, this is a linear equation, this is one line, this is second line, this is third line. Tell me which one could be possibly the answer. I will blindly choose this one. Why? Because I see that intercept it is touching the y-axis at -2. This is the place where I see it going towards the negative of y. And then my slope is positive, so it is increasing. This guy is decreasing, this guy is increasing but not touching y at -2. So I'm ruling out this guy, I'm ruling out this guy. This is my potential answer. Yeah? Are you guys able to relate this concept of linear equation, slope, and looking at that as a slope intercept form? Everybody, I will ask everybody one by one. Myra, you understood?
Yes, sir.
You cannot say no after the class, okay? Alright, let's check with Kartike and Sam. Did you guys follow me what I said?
Yes, sir.
Yes, sir. I wrote it down in my notebook.
What is it, better?
I wrote it down in my notebook.
Okay. I don't prescribe you guys, I don't recommend you guys to worry about taking notes while in the class, because this video that I make, the quality of YouTuber I only have you guys as my subscribers, so don't worry about it. It's only for you guys, okay? Nobody else watches my video and they don't need to watch my video either.
Diamond play button.
Wait, what do I type in to find your channel?
Wait, what is that?
What do I type in to find your channel? Because I've been typing Vinu Kumar math lessons.
No, you can search for yes, I am from Bihar. That's where you'll find it. Anyway, okay, he knows it.
Do you have a diamond play button?
Wait. I'm not interested in talking about YouTube. I'm not wanting to become a YouTuber either. These videos are only for you guys. That's what I was trying to say. And again, when you go way too far on the Google map, I have to bring you back. That's a waste of extra fuel that will take for bringing us back. Okay, now the destination is different. What I was saying was, if you take notes or you don't take notes, it will not hurt you, because you have video for your reference, and it is only for you guys, nobody else. Okay, so if you take notes or you don't take notes, in both ways you're fine. I would suggest not to worry about taking notes, because when you're busy taking notes, you might miss some of the concepts that you have to follow otherwise. Okay, all right. So Myra said yes. Sagnika, Dikshita, both are fine. Everything understood well. And you'll be surprised to know that these concepts are actually taught in high school. You guys are learning little early.
Yeah,
I thought my dad taught part of this in when I was in 5th grade, and he gave me one worksheet about it. But it was not.
Okay, it's fine. Even if it's for 8th grade, you are still learning it 2 years ahead of time.
But see, people still learn it in 5th grade.
They are mad people. I would not want to talk about them. You have to. If you learn everything that you're supposed to learn in college now, what will you learn in college? How to make bombs? Don't do that. So what I'm saying is, go with time. Don't rush. If you just rush for everything, there'll be a time. People want to become CEO at the age of 18. What will you do when you're 45?
Get a job.
So again, don't rush for things. Enjoy every bit and piece of learning that you come across. Learn it in a way that it builds your personality. You should be able to explain things. It's not about solving 50 problems in a day. It's about knowing one concept which helps you solve thousands of problems of that kind. Focus on concept rather than rushing for answers. That's what I keep asking you guys. And I keep making that blunt statement saying I don't care about the answer. And I want you all to say that. You don't have to care about the answer, because answers is very local. It has no bearing with what you know as a concept. I can mug up an answer without knowing the head and tail of the question even.
That's just something my dad.
So don't do that. So Pranav, Bivan, Sanvi, Lokshita, everybody understood whatever I said?
Yeah, I understood.
Okay.
Yes, sir.
Whenever I blabber, just let me know, okay?
Sure.
Alright.
Yes, sir.
So enjoy your rest of the evening. Have fun. Just few more hours left in the weekend. See you guys next Saturday. Wait for the video to be uploaded latest by tomorrow. And I'll give you assignment. Huh?
When I'm home, are you gonna send it?
Yeah, I'll send the homework by Monday evening or Tuesday evening.
We'll have 10 questions.
Huh?
Can I have 10-20 questions?
I will only give limited number of questions, which I believe is enough for you guys to at least make sure that what you have learned is, you're able to apply that.